Hello guys, welcome to our video on unlocking the secrets of platelet detection. In this video, we will explore the fascinating world of platelet detection. But before we dive in, let's first take a look at what we will cover. First, we start with introducing platelets, understanding about impedance, composition of blood, electrical properties of RBCs, WBCs, impedance-based platelet detection, and alternative detection methods. So let's kick things off with a closer look at platelets. Platelets are small, dish-shaped cell fragments circulating in the blood. They aggregate at the site of injury to form clots, preventing excessive bleeding. Normal human beings should have around 150 to 450,000 platelets per microliter of blood. Now let's get to grip with the concept of impedance. Impedance encompasses all forms of opposition to electron flow, which includes resistance, capacitance, and inductance. In the context of platelet detection, impedance plays a crucial role in measuring the changes in the electrical properties of the cells. So before we move on with platelet detection, as the blood is a complex mixture, understanding their components is crucial. So as you can see, the blood comprises of plasma, red blood cells, white blood cells, and platelets. Plasma is mainly a water, carries proteins, ions, nutrients, and waste. RBCs transport oxygen, and WBCs are crucial for immune response. As we are here to detect platelets using impedance, the knowledge of which are going to conduct and which are going to resist is very important. As the plasma mainly contains water and ions, we put them into completely conducting basket. But RBCs possess unique electrical properties. So let's uncover them. So RBCs possesses an insulating membrane and biconcave ellipsoid shape, affecting the conductivity of the blood. They are electrically anisotropic, that is, their conductivity changes with the change in position. We call it as orientation induced impedance. So as you can see, on applying the magnetic field, it changes its position. So by keeping the RBC in the direction of electric current will help them in eliminating the RBC's impedance while calculating the impedance, where our interest is mainly on platelets. So now let's explore the electrical properties of white blood cells. White blood cells has a cell membrane which consists of pores and act as a leaky dielectric due to the presence of lipid structure. So they have a double shell electrical modeling where membrane acts as a capacitance, cytoplasm and nucleus act as a resistance. Solving this complex structure will get the final impedance as this. So from knowing the formula, we can eliminate the impedance created by WBC on calculating impedance, where our interest is on platelets. But this is not as easy as I said, and we need the count of the RBCs too, RBC and WBCs too. By using the electroporation method, that is the use of short high voltage pulses, we can overcome the barriers of the cell membrane, thus eliminating the capacitance produced by capacitance of the cell membrane. So by understanding their impedance changes, we can develop sensors for detecting the WBCs. So finally, let's uncover the impedance based platelet detection process. In impedance platelet counting, cells are considered as non-conductive resistivity particles. Change in electrical impedance when cell passes through a sensing zone allow for detection and categorization based on their volume. So as we will be eliminating all other blood components which contribute to impedance, we use the Coulter principle to detect and count the platelet by passing the blood through a small aperture. But This is not as easy because we have to eliminate the impedance of RBCs and WBCs. Um, but by performing the experiments, we can get to know how well we can eliminate those stuffs. So let's see what are the alternative methods and let's explore them. So beyond impedance, alternative methods for platelet detection include platelet analysis, flow cytometry, and dielectrophoresis. Each offers unique advantages in accuracy and specificity. So let's dive into dry electrophoresis and its role in platelet detection. Dielectrophoresis exploits electrical forces on dielectric particles, as these cells are non-conducting things. As you can see, the cell membrane is a non-conducting part of the cell, so we can consider them as a dielectric medium, and we will be exploiting the electrical forces on the dielectric particles in a non-uniform electric field. By manipulating the electric field gradients, platelets can be separated from other blood cells, offering a more promising avenue for efficient detection. A major disadvantage of this method is the difficulty in distinguishing the large platelet cells from extremely fragmented red cells, fragmented WBCs, and other similar sized particles. So this may result in false increase in the report of platelet count, and this difficulty is due to the discriminator used based on the size to segregate the uh, platelets from RBCs. Next is the flow cytometry. Offers other The flow cytometries offers other avenue for platelet detection. Let's explore its capabilities. So flow cytometry detects platelets based on their optical properties and fluorochrome signals. As platelets pass through the beam, they scatter light in a manner that provides information about their size and granularity. Platelets emit fluorescence when excited by the laser. The signals generated by the light scattering and fluorescence detections are processed and analyzed, uh, by which we will be detecting the platelets. So, optical platelet analysis provides valuable insights. Let's see how it works. So, it's just the combination of impedance and light absorbance method, as we saw before, flow cytometry. Optical methods utilize the light scattering to determine the platelet characteristics by measuring the volume, that is the resistivity, and refractive index. Optical analyzer differentiate platelet from other blood components with high precision. Another method include using of miniature microscope for detecting the platelets in blood. By using tunable miniature microscope, we can analyze the WBC, RBC, and platelets at once too. So, in conclusion, platelet detection is a critical aspect of medical diagnosis. By leveraging the impedance and various other techniques, we can enhance the patient care and outcomes. So, thank you for watching this video. We will come up with more interesting video like this.